Good morning, class. Welcome to the course COS 102 Introduction to Programming. In this course, we will be demonstrating some basic programming concepts using Python. COS 102 Introduction to Programming. We'll be demonstrating with Python programming language. Now, with the Python programming language, there are IDEs, Integrated Development Environment, and you also have the console. At this stage, we will be using the Integrated Development Environment called Jupyter Notebook. We will use Jupyter Notebook in writing our codes. Now, the Python compiler itself is a calculator. You can use it as a calculator. So if you write 3 multiplied by 2, it will output 6 for you. If you do any arithmetical operation, calculation, 5 plus 7, it will give you 12. If you do any of this, it is going to give you the calculated value correctly. However, the board mass, the concept of board mass applies. So, board mass meaning brackets of division, multiplication, addition, and subtraction. So, if you have something like this, 5 multiplied by 3 plus 2, the cost of board mass is going to do your 15 plus 2, which is going to be 17. So you have to look at board mass, and you have to know what board mass is and do your calculations accordingly. Whether you do it or not, the Python compiler is going to do that for you. Now, one key concept we have in programming is a variable. What do we mean by a variable? It's a key concept in programming. What is a variable? Now, in mathematics, if we have x equals x plus 5, this is not obtainable in mathematics. But in programming, this is obtainable. When we have x is equal to 5, let's start with this. It means this is now a variable. What do we mean by a variable? A variable is a container. And what is here is the value assigned into the container. If you look at this bottle, the container is the plastic bottle, but the water inside is the value, the content of it. You can pour this water off and add something else. So the container remains, but the content could change. That's why it's called a variable. So if we do x equals 5, and then with x, we run x, it's going to give us 5. 5 will be because x is contained, 5 is contained inside x. But if you, after this, do x is equal to 7, and we run x, this time it's going to be 7. If we do x plus 5 at this point, it's going to be the 7 you have plus the 5. And then that is 12. If you do this, what this means is that whatever is inside x what is contained in X, add 5 to it, and keep it back inside X. So the equal to sign is called an assignment operator. An assignment operator. You are assigning a value into the variable. You are assigning a value into the variable. So the variable is just like this. You have a container called X, and inside it, as in this case, is written 5. You can delete this one and change it to 7. You can change it to 15. You can change it to anything. So the container is different from the value. That is a key concept in programming. So we have the assignment operator, the equal to is an assignment operator. Now, after we talk about that, there's another operator we have to differentiate these values. There are other operators. If you look at arithmetical operators, the arithmetical operators. In the arithmetical operators, you have addition as in adding plus, subtraction, division, multiplication. These are basic arithmetical operators you are going to use at this point. So you can do arithmetical operations using these values. Now, we now want to combine the arithmetical operators and the assignment operator. So if you now have x is equal to 5, you have assigned x into the variable 5. If you now say x equals x plus 3, you have added 3 to 5 and store it back in x. So looking at this, grammatically, it will be like this, and you have 5 at this point. Then at this point, you now have the x will now be what is there, adds to 3, and that gives you 8. So that is assignment operator, and that is variable. So we understand what we mean by a variable, we understand what we mean by an assignment operator, and we understand how the variable value changes as we go on. Now, the next thing we have also looked at arithmetical operators, addition, subtraction, multiplication, and division. We have also looked at that. Having looked at that, we will now look at other operators. Before we look at those operators, let us look at Boolean expressions. Boolean. We have relational operators. Let us look at relational operators first. Relational operators. We look at relational operators. Now, before we say anything, let us look at this. 5 is greater than 8. Is that true? No. If you key this in the Python compiler or the Jupyter notebook and you run this, the outcome is false. False. Telling you that 5 is not greater than this. But if we do 5 is less than 8, this is true. So the outcome is true. So what are we trying to say? That the outcome of relational operators is true or false. We have to bear that in mind. Now, having known what this is, we'll look at what is called the truth tables again. We look at truth tables. Now, in the truth table, we are going to, at this point, we are going to look at 2 major truth tables. Or operator, and then we are going to look at and. Or and and. Let's look at the truth table. If we have A and B, we do that. We have 0, 0, 0, 1, 1, 0, 1, 1. We have A or B. 0, 0 will give us 0, 0, 1, or operator 1. This will give us 1, and this will give us 1. Now, let's draw a circuit diagram of what that means. If you have this, 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 and you join this together, and then you draw this, and this is the negative of a bulb, and this is positive. Here you also have positive, and you have a bulb at this end. You have a bulb at this end. You will agree with me that if this is connected to the bulb, if you switch this on, the positive current will pass here and this bulb will come on. If you switch this on, while this is off, the current will still pass and this bulb will be on. If you switch the two on, the bulb will still be on. Now look at this. If this is off and this is off, this is now A and this is B. If this is now A and this is B. If it is off and off, this place will be off. If it is off and on, this place will be on. If it is on and off, this place will still be on. If it is on and on, this is will be off. On. So this is a demonstration of the OR table, and that is why this table works. So that is one operator. Then we look at the AND operator. In the case of the AND operator, we have A or B. Then if we look at the AND operator, we have this bulb coming here. This is the bulb, and then you have your negative, and you have your positive here. You have A and you have B. Now, this is A, this is B, 0, 0, 0, 1, 1, 0, 1, 1, and then you have A and B. Now, you will agree with me that if you on this, and this is, okay, this is off, and this is off, this bulb will be off. If this is off and this is on, the current will not pass through here, so this bulb will still be off. If you on this one and you off this bulb will still not go on, it will be off. But if you on this and on this, then this bulb will come on. That is an on and operator. So that is how it works. So we have to recognize this because we are going to use this in our operations, in our relational operators. So this 0 means false, 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 and true. When you come over here, this is false, true, true, and true. Having gotten this, we can now look at a combination of some of these operators. We look at greater than or equal to, less than or equal to. Bearing in mind the OR operator, bearing in mind the OR operator. So if we say 5 is greater than or equal to 8, will that give us true or false? If you look at this, 5 greater than 8, that's false. 5 equal to 8, that's also false. So you get false, false, so that will give you false. One thing we have established, the outcome of the relational operators is always true or false. They are used in deciding, knowing the condition, the outcome of which we are of a situation. So from those conditions, we can now go on to do some other things. So greater than, greater than or equal to, less than or equal to. We have demonstrated greater than, we have demonstrated less than. Then another operator we have is the double equal to. The double equal to, the outcome is also true or false. What this means is you are comparing. So you are comparing these two. Is A and B, are they equal? That's what you are doing here. Are they equal? Remember, it is different from this. In the second case is an assignment. Whatever is in A is transferred and also duplicated into, whatever is in B is duplicated into A. While in the first case, you are comparing. So if we say A, we assign to A 10 and we assign to B 15, the statement A, B is going to give us false because A and B, 10 and 15, are not equal. It is like doing something like this, comparing these two. So the result is going to be false. But if we have C as equal to 10, then C equal to A, because C is 10 and A is 10, this will give us a true value. True. True can be represented as 1, while um, false can be represented as 0. So having gotten this, let's go a little further again. Now we look at the word print statement. If we do print, if we say print, this is a boy, this is called a string. We will later look at data types, in which case we are going to talk about what is a string. But at this point, the important thing we have to know is that when you put the print statement, open and close bracket, whatever you put in quotes will appear on your screen. So when you run this, what will appear on your screen is this is a boy. That's what will appear. So we can put that. However, we can do arithmetical operations inside a print statement. We can do arithmetical operations inside a print statement. The outcome will be 7. Now, we have string. String data types are characters. We will later go into details of that. However, let us demonstrate some concepts here. String data types mean they are characters. Now let's look at an example. If I say print 5 and I say print 5, these two 5s are not the same. This is a string, a character data type, while this is an integer. Now, what do we mean by a character or string data type? Example, If you go to your street where you live, the building with the building with the number 3 and the building with the number 2 are different. But does the building number 3 and the building number 2 add up to get to the building number 5? No, that's not true. The buildings are different. In this case, the numbers are used as string for the purpose of labeling. They are used to label for the purpose of identification and cannot be used in arithmetical operation. So, this is a case of a string, while this is a case of an integer. However, let us look at something like this. If you do this, the string plus 2, plus 2, this will throw an error because this is a string and this is an integer. So you cannot add an integer to a string. So that is not possible. So it's going to throw an error. However, if we do something like this, it is going to work. It's going to work. But what is the result? Let us try this again and do this. In this case, in the second case, this is an integer and this is an integer. So the outcome of this will be 10, 2 multiplying 5. But because this is a string, this will give us 5, 5. We are saying double this string. That's what this will mean. So when we write our code, a very important thing again, when we write our code and our code is running, does not necessarily mean we are getting what we are supposed to get. When you write your code and you run your code, you must have to check, to test, to see if that is actually what you want. The code is running does not necessarily mean you have gotten it right. So that is about string, using string and integer in your print statement. Now, if you do print again, if you do print and you say the string 5 plus 2, what this will mean is the outcome of this will be 5 and 2. Concatenation. This is called concatenation. You are bringing the two strings together. I've made it a string. So I'm just bringing the two strings together. So it is not going to give you 10, but it's rather going to give you 5 and 2, which is 52. But the 52 is a string as well, not an integer. So let us look at that. Now let's look at another simple concept here again. The input statement. Input statement. What does the input statement mean? This is what we do. If I say a variable Nick is equal to input what this input will mean is that when the code gets to this point, it will wait for you to write something, to key in something on your keyboard. In the Jupyter notebook, it's going to open something like this for you to type in. Now, how do you know what you need to type in here? We are now going to write something, a string in here. If I say enter your name, and we run this, the output of what we will see is enter your name. What the system will do is it will print this, enter your name out here and create a box for you because of this input where you have to key in something. When you key in that thing and you enter, without that, the system will not, the program will not run beyond this. It will be waiting for you to key in something. So you key in whatever you put here and you say enter. Note, whatever you key in here is a string. Whatever you key in here is a string, whether it's a number or whatever. So at this point, we would like to wrap up what we have done this much so that we will continue in the next video. Going back, we'll see that we described, we talked about nothing. We talked about variable, what is a variable, we explained what is a variable, we saw how we change the variable value changes, we looked at the assignment operator, we looked at the comparison operator, we looked at the relational operators, greater than, less than, greater than or equal to, less than or equal to. We also looked at the truth table. We looked at what the truth table is. We showed how this could be used in a circuit. We looked at the AND table and we also looked at ordinals. After which we also looked at our print statement, how the print statement works, concatenating string, and then we saw how we could do some arithmetical operations in a print statement. At this point, we are going to end this here and then continue our practicals in the lab. In the lab, we are going to practically demonstrate everything we have done, and then in the next class, we are going to continue. Thank you very much. I'll see you in the next video. Thank you.